Okay, so now we're going to solve a system. In the last problem, they gave us a solution and we checked it. But what we want to actually be able to do is solve a system of equations. These systems are bigger. There's 3 variables and there's 3 equations. So it's going to take more time and more paper. Try to check your steps as you go along. That'll save you some mistakes and make it easier to work with. The other thing is to try to be organized. I'm going to give you some steps as I do this problem, but you kind of have to have some rhythm and logic. And after a couple problems, you'll say, okay, this is the way I like to write it, and hopefully it'll work out for you. Okay, so step 1, you're going to choose 2 equations to eliminate a variable. Now, we're going to be using the methods we learned in 5.1. There's elimination by addition, or the addition method, and there's substitution. Those are the methods we have, and that's what we're going to use. There are other methods, but they're not discussed in this class. You have to take another math class to get those. Okay, so I'm going to pick 2 equations. I'm going to pick the top 2 equations. Now, there's really, you could pick, the top one and the bottom one, or the bottom 2 equations, but we have to eliminate a variable. Just look at them and see, well, what variable do I think would be best to eliminate? Now, some people would say X, some would say Y, some would say Z. I'm going to eliminate Z, okay? So I'm only looking at the top 2 equations, so let me write those out. I'm going to take a little more paper than I normally would. In the next problems, I'll show you a little bit shorter writing. And there's a lot of copy work in these problems, so be careful and make sure you're copying it down correctly, like double check it before you go on. That's much easier than making a mistake and not catching it till the end, and then you have to go back and redo it and stuff like that. Okay, and I already told you I'm going to eliminate the z. So what I'd really like is to have a negative 4z and a positive 4z. So I'm going to multiply the bottom equation by 2. So we've done this before when in 5.1, where we multiplied by something so a variable would eliminate. The top equation, I'm just going to copy that down. Yeah, lots of copying. Okay, now when I multiply by 2, I multiply the whole equation. So that's going to give me 6x plus 6y plus 4z equals negative 6. And then I'm going to add those equations. I get 11x plus 4y, and the z's drop out, equals negative 3. Okay, that's great. We want this equation. We're going to keep that equation. We're going to need that later. Okay? Step 2. Pick 2 different equations. So, you're going to have to do a different combination and eliminate the same, this is important, the same variable. So because I eliminated z, I'm going to pick 2 new equations. I also have to eliminate z. So I'm going to pick the top equation, the 5x minus 2y minus 4z equals 3. And I can't pick the second one because I already used that one, but I can take the bottom one. Negative 2x plus 5y plus 3z equals 3. Now I am tied to eliminating the z's. And the reason is because I need another xy equation so that I can put those 2 together and solve. Okay? So I'm going to multiply the top by 3 to get a negative 12. So I'm looking at these z's and I'm thinking negative 4z and 3z. I want them to be a negative 12z and a positive 12z. Okay. And then this one I'm going to multiply by 4 to get that positive 12. So it's like finding an LCD, that kind of thing. So I multiply. I get 15x. So I'm distributing this 3 minus 6y minus 12z equals 9. I have to go all the way across. So I'm multiplying, the first two and the third one, and then the answer as well. Okay, then let me double check those. 15x minus 6y minus 12z equals 9, I think so. Now I'm going to do the bottom one. Negative 8x plus 20y plus 12z equals 12. Sometimes the numbers get a little big, but that's okay. All right, so here we go. Adding, I get 7x, I get 14y. The z's drop out. That's supposed to happen. That's what I was planning on, kind of counting on. And 9 and 12 is 21. Okay, so now I have these two boxed equations with stars by them. Those are both xy equations. Now you're back to a 2 by 2 system. Okay? There are some things we can do to make it a little bit easier. We could divide by 7 here, and that would make the numbers smaller. A lot of times people don't think of that. And you'd be okay if you just went bigger. But now, step 3, you're going to take the two equations, and they only have two variables in them, and solve for a variable. It's either going to be x or y in this case. Okay, so I have this system. Where can I put it? 11x plus 4y equals negative 3. And then I have that x plus 2y equals 3. Okay, so what if I multiplied this bottom one by negative 2? Then I'd have a 4y and a negative 4y, and the y's would eliminate. So that's what I'm going to do. And I get 11x plus 4y equals negative 3. And then this one becomes negative 2x minus 4y equals negative 6. So then I can combine those, add them. I'm going to get 9x, because 11x minus 2x. The y's are dropping out, and it equals negative 9. Well, I like the looks of that. This is going to come out to be an integer. It doesn't have to, but it does make me feel better. And I get x equals negative 1. Yay! Okay, now, what number step am I at? 4. Back, substitute. To a 2-variable equation. Okay, so now I could pick, I'll circle the ones I could pick. I could pick this equation. I could pick this equation. I could pick this equation. One of those, though. I'm going to use this one right here. The x plus 2y equals 3. So I have x, well, let me just write it. X plus 2y equals 3. But I know what x is. X is negative 1. So I'm going to put in negative 1 plus 2y equals 3. And then I can solve. Add 1, divide by 2. So I get y equals 2. Okay, so now I know what x is and I know what y is. Now I have to back substitute to a 3-variable equation. So this is step 5. Back substitute. It's like you're working your way back. It's one of the original equations. Okay, so one of the original equations. Now I can kind of see one of those right here. So I'm going to go with that one that I can see, and I'm going to write it. I'm kind of scribbling through my stuff. I'm going to write it right over there. So I have negative 2x plus 5y plus 3z equals 3. And then I'm going to put in my x and y that I figured out. Negative 2 times negative 1, because x is negative 1, plus 5 times 2, because y is 2, plus 3z equals 3. Okay, so now I have to figure stuff out. Negative 2 times negative 1 is 2. 5 times 2 is 10. 2 and 10 is 12. If I subtract 12, I get 3z equals negative 9. And then finally, if I divide by 3, I get z equals negative 3. Okay, so I did it. I found the ordered triple. So I'm going to write it as an ordered triple, x comma y comma z. So we've not had ordered triples until just now. We've always had ordered pairs. But now we're going into a bigger dimension, and now we can have ordered triples. Okay, so my answer is going to be negative 1, that's x, 2 for y, and negative 3 for z. Now you could check those in each equation, each of the original equations, to make sure it's true. Or you can wait for the little green check in my Pearson lab, or my lab, and then that'll make you happy too. Okay, so they're kind of long. It took us 11 and a half minutes to do that problem, but it's exciting, right? It's big, but it's pretty cool the way it all works out. All right.